Hello guys, my name is Desmond and I welcome you to my lesson for today where we'll be looking at mathematics, obviously part of paper 2 as you can see over there. So ladies and gentlemen, I welcome you and please do allow me to say it is very much important that I say it is very much important because what I'm about to say, it's massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. Shravan. By so saying, please make sure that by the end of each and every lesson that I conduct, all of you guys make sure that you learn something new. Okay, so ladies and gentlemen, in today's lesson, I'm going to take you through trigonometry, which is part of paper 2 of your mathematics. I want to take you through the rules, namely the sine, the cosine, and the area rule. But before we get to this rule, those three rules, I would like to quickly take you through a revision regarding a right-angled triangle. I just noticed some of you guys are joining my lessons for the very first time, and I'm hoping you guys will enjoy today's lesson. So just so that we don't leave everyone behind, I'm just going to quickly take you through a very short and quick revision on a triangle. Remember, guys, the whole of last month, I think I've been talking about triangles, taking you through the importance of interpreting and noticing a triangle. So, guys, there we've got triangle number 1, triangle number 2, triangle number 3. What is a triangle? A triangle has got 3 sides and 3 angles. Very much important, ladies and gentlemen. And also, it has 3 points. For example, there's a point, there's a point, there's a point. 3 points, 3 angles, and 3 sides. So if that point is A, this is B, this is C. It simply means that the angle there is the angle for point B. The angle there is the angle for point C. The angle there is the angle for point A. So the side opposite to this angle, it is that letter but in small letter. Very much important, ladies and gentlemen. So that angle A, that was angle B. That angle A there, the opposite side to this angle is actually small letter of that same letter. Here we've got angle C. The opposite side is smaller yana C over there. Very much important. So A, B, C. Then we're going to have D. Let's say E. And then we say F. The same thing can be explained on this triangle. A, B, C, D, E, F. Then let's have got G, H, I. Ladies and gentlemen, I want you to notice something. On these 3 triangles, triangle 1, triangle 2, and triangle 3, which one or which ones are right-angled triangle? Just mention your name and I will recognize you, honorable member. No response. I'm just not sure if it's because the message is on its way, but it's fine. Let me continue. So, good people, it's either you have a triangle, or you have a right angled triangle. So how do you notice a right angled triangle? That's where you see this sign, which is that one, meaning this one, triangle number 3, it is a right angled triangle. But can you see on triangle 1 and triangle 2, we do not have this thing. And also, there is no statement which tells that triangle number 1 or triangle number 2, it is a right angled triangle. Therefore, even though this one, triangle number 2, it looks like it's a 90-degree angle there, but because there is no that, then we cannot assume that it is 90-degree angle there. What if that is not a 90-degree but is 89.99? Can you see? So only if they did this, then you know it's a right angled triangle. But now, why is it important for us to know if a triangle, it is a right angled triangle, or if it is just a triangle? Remember, guys, a triangle, it's either it is a right angled triangle or it is just a triangle. So the reason why it is important for us to know if we are dealing with a right angled triangle or not is because always, when we have a right angled triangle, which is triangle number 3 in this case, it's because we can use the trigonometric ratios being sine, cos, tan, and lastly, theorem of Pythagoras. So that means we can use 1, 2, 3, 4 things. Only if you are dealing with a right angled triangle. But if it is not a right angled triangle, you cannot and you can never use these 4 things. But in today's lesson, I'm going to teach you exactly what you can use in case if you are not dealing with a right angled triangle. Ladies and gentlemen, what I'm going to do quickly is for us to do a very quick example on a right angled triangle. And then from there, I'm going to move to the second part of today's lesson. Are you guys happy with all that I've explained up to this point? Or is there someone who's got a question before I move on to the next part? Hmm? Any questions, guys, or do I move on?
No questions.
No questions.
Okay, 100%. Let me therefore quickly give an example of which I'll go through that example so that we move quick on this one. Remember, this is not my first time doing this. So just in case if you missed my previous lessons, just make sure to request a link where you can catch up. And also, it is not my last time doing this. I'm telling you guys, towards exams, I should make sure that I do a bit of a revision with you guys. So let's say for some reason, we are given this thing. And it's given as that being point A, this being point B, this being point C. And they say we've got 37 degrees over there, and then we've got 16, let's say, maybe the unit is 16 centimeters. Ladies and gentlemen, always, the moment you start seeing a triangle, ask yourself this question. Is this a right-angled triangle or not? Can you see, guys? I don't see that sign that confirms that it is a right-angled triangle, which means I'm not sure at this stage if this is a right-angled triangle or not. If I'm not sure, I cannot assume it to be a right-angled triangle. But the moment you see this thing, then you can just say ehua. Reason to that is because you know very well that you can easily use sine, cos, tan, or theorem of Pythagoras. So now the question may be, on this right angled triangle, calculate the length of AB and BC and also angle A. So let's say length of AB, again length of BC, again angle A. I'll quickly do that, ladies and gentlemen. Okay, because I know this is a right-angled triangle, then I know this side being small letter b. Why small letter b? Because it is opposite to that angle. So that means this is actually smaller than a, this is actually smaller than c. Okay, so obviously we are given that being 16, meaning this is actually opposite, because this is the side which is opposite to the angle. So that means this side is adjacent, and always the side which is the longest side guys, can you now hear me? I just noticed the network is poor on my side, but can you guys hear me now?
Sir.
Yes, sir.
Which
Yes.
which part did you not hear me when I was giving information there? Or maybe you could only hear me up to which part?
Yes, sir.
Okay, I notice it's taking some time for the message to deliver, but it's fine. Let me continue. So what I was saying, ladies and gentlemen, is that in this triangle ABC, we've got this side being the opposite side because it's opposite to the angle, and then we have a 90-degree there, and we know that the side which is opposite to the 90-degree angle, it is the hypotenuse, which is the longest side, and then obviously BC is our adjacent. Okay, so now let's see, how can we possibly find AB? So AB, let's see, AB, it is actually hypotenuse, and then we also have opposite. So which trig ratio has hypotenuse and opposite there? I think it's Sine Sine. Sine is opposite over, yes. So I think sine, sine of what? Sine of that angle, which is sine of 37 degrees, is equals to opposite over hypotenuse. What is opposite? Opposite is 16 over hypotenuse is AB. AB, all of that is equals to that. So obviously you cross multiply. That times that you've got AB being equals to AB sine of angle being multiplied by 16. So now, because we're looking for AB, we can just divide by that sine 37 so that it cancels. Remember, whatever that you do on the left, you also do on the right. So we divide by sine 30 that. I hope everyone is familiar with this calculation. Just in case you're not following there, just make me aware so that I can actually explain in simple. So what is the answer there? What will be the length of AB? So because I did not specify correct which decimal places, in case if it's a decimal, round it off to 2 decimal places. What is the answer there when you punch on a calculator?
It's 26,59.
What is it?
26,59.
26,59. Do you guys agree with that? Okay, so now that we've got our hypotenuse, how can we possibly calculate AB? Can you guys see? We can still use the trig ratio, or otherwise we can use Theorem of Pythagoras. So we now have more choices of calculating the other side because we have too much information. So maybe with Theorem of Pythagoras, if you formulate, it's going to be AB squared is equals to, you can say, BC squared plus AC squared, meaning hypotenuse is equals to that side plus that side. Okay, so now let's see. What is AB? AB, we just calculated it. They say is 26,59. What is BC? BC is what we are trying to calculate. Plus, what is AC? It was given as 16 squared. As 16, and then we square it because of the formula says squared. So we can transpose. Remember, it changes a sign. So that means you've got 26 that minus 16 squared is equals to BC squared. Can someone punch all of that and let me know what are you getting when you punch all of that? This is what I'm getting, guys. I'm just not sure if the message is still on the way, but this is what I'm getting. So now I'm going to introduce a square root on both sides, and the reason to that is so that I remove that squared over there, meaning BC is equals to square root of an answer which is equals to 21,24 centimeters. I'm just not sure if you guys agree with me on that one. But I think you're also getting the same answer, isn't it?
Yes, sir.
100%. So now let's see, we've got that side being 21,24 centimeters. Okay, so we have all the sides 1, 2, 3. We have that angle is 37 degrees. We have that angle is 90 degrees. What is the value of that angle, or how can we calculate the angle of angle A? I'm not sure if you guys remember that. The sum of interior angles of a triangle are equals to 180. Meaning, always if you have a triangle, when you add angle 1, angle 2, and angle 3, they must all be equals to 180 degrees, which means angle A plus angle B plus angle C must be equals to 180 degrees. So angle A is what we are trying to calculate, plus angle B, what is it? It was given as 37 degrees, plus what is angle C? We know it is 90 degrees. All of this must be equals to 180 degrees. All that you do is just to transpose. So that means you have 180 degrees minus 37 degrees minus 90 degrees. What are you getting there when you punch all of that? Hmm?
53, sir.
I'm getting 53. So that angle over there, it is 53 degrees. Be careful. Say 180 degrees minus 37 minus that, because you're taking all the angles to one side. And when they get here, they change a sign. Be careful of that. Remember, guys, with just a very small mistake, can make sure that you get everything wrong. So this is all that you guys have to be aware of regarding a right-angled triangle. So now I'm going to now take you through the area rule. So everything that I've just explained now is all that we have done previously. To some of you guys, it's a revision. So now, please do allow me to take you through the area rule. But lastly, remember, it doesn't necessarily mean that always a right-angled triangle will be in this shape. Again, examiner can try to spice things up and draw something similar to that. And then if they do this, then you know this is a right-angled triangle because of that. The moment they put an angle there, then it means this is your adjacent, this is your opposite, this is your hypotenuse. But if they don't give you that angle, you cannot tell which side between these two is adjacent and which one is hypotenuse. You can only tell that this one is hypotenuse, but you must wait until they give you an angle. If they say the angle is that one, then automatically it makes this side adjacent and that opposite. But if they talk about that angle, automatically it makes that side adjacent. What they like doing is to say A, B, C, and then they say in triangle A, C, B. What is angle C? Can you see? So they did not write theta there, but because of this statement or the manner in which that is written, it simply means in triangle A, triangle C, triangle B. we are concentrating on angle C, which means the angle that they're talking about is that one. Automatically, this side is adjacent and this is opposite. Just be careful of that, ladies and gentlemen. Okay, quickly, I would like to take you guys through the area rule. The area rule. So remember, guys, I'm actually doing this lesson for the very first time, which means it won't be my last time doing this lesson. And again, I haven't done proper notes. And once the notes are done, I'm going to send them in the library. So for those of you who are writing, don't worry that much about writing. For now, you can just be listening and making sure that you pay full attention. As soon as the notes are done, I'm going to send them in the library. And again, this lesson is being recorded. You can be able to catch up at a later stage. Okay, the area rule. So remember, guys, in this case, we are actually going to be talking more about the area, obviously. Remember, it's either you have a right-angled triangle, or you just have, for example, let's say a triangle similar to that. Let's say this is A, this is B, and this is C. Maybe this is D, E, and that is F. We do know very well that the area of a triangle is equals to half multiplied by the base multiplied by the height. We know this as the area of a triangle. But I want to quickly take you through the formation of this formula. You know, guys, it's very, very much important that you understand where these formulas are coming from. They don't just come from anywhere. So before we can have that formula of a triangle, it first started as the area of a rectangle. Remember, a rectangle, that is going to be the breadth, and this is going to be the height. So the area of a rectangle we know is equal to breadth multiplied by height. And remember, guys, this height is that straight line height. Straight line height. This is straight line also. So it's more like we have 90 degrees angles there. Because a rectangle, it's a shape whereby this side is equals to that, that is equals to that, and also the interior angles are equal. So the moment you start cutting this rectangle, maybe let's say you cut it like that. Can you guys see that this rectangle, you've actually cut it into half? So that means this half or this side is actually equals to that side. Very, very much important, ladies and gentlemen. So here you already have a triangle. Let's see where that triangle comes from. It comes from, it's more like it was a slice of bread, guys, which is cut into half. And there you've got that 90-degree angle. Can you guys see that? This side, it is therefore equals to that side. So it was actually breadth and what is it? Height being that side. But because of now, we are actually trying to find the triangle of the area of a triangle. Then it ends up being the area of a triangle is equals to half breadth times height. Very, very much important, ladies and gentlemen. So now, that was the explanation on a right-angled triangle. What about on this triangle, which is not a right-angled triangle. Can I also be able to explain on that one? Let's see. Remember, guys, I just said it firstly started as a rectangle or a square. It doesn't really matter that much. Let's say, for example, this thing is somehow being cut such that what is it? It's being cut such that it actually has this triangle. It's going to be interesting there. So obviously, let's say we've got A, B, C, D, or whatever. It doesn't really matter that much. I just want you guys to notice that this is the breadth, this is the height. And we said the area of a rectangle is equals to breadth multiplied by the height. But now, this triangle is it actually equals to this side and that side? Let's try to check. If you do that vertical line in between, remember the vertical line, you start it from where those two lines join. You go down with it. So can you guys see that we actually have a right, a right, a right, and a right there. So it's more like we have one triangle, triangle 2, triangle 3, triangle 4. So triangle 2 and triangle 3, you can see that there, let's see, you have that triangle, which is actually equals to that triangle. You also have this triangle, which is actually equals to that triangle. So that means it doesn't matter whichever the shape of a right, it doesn't matter whichever the shape of a triangle is. As long as it is a triangle, the formula for its area is 1 over 2 b times h. And the h that we are talking about is that one h from there, which is that h from the top going down up to there, where you have 90 degree, you also have 90 degree. Don't confuse the h and say maybe the h will be this side, or maybe the h will be that side. No, the h is the one from where these two lines join, and then you do a dotted line, and this is the h that we are talking about. Meaning the h that we are talking about is that one, which is from there up to there. So that is the vertical h, the vertical h that we are talking about. Very, very much important, ladies and gentlemen, over there. So, and again, let me maybe try to draw another triangle which might look a bit funny. Let's say something similar to that. Let's say something similar to that. Is this thing a triangle? Yes, it is a triangle. Is it a right-angled triangle? No. Why? Because we don't see that sign. But we know it is a triangle because it has 1, 2, 3 points. It has 1, 2, 3 sides. It has that, 3 angles. Something very much important, guys. If you had to calculate the area of that triangle, you just know that it is half multiplied by breadth multiplied by the vertical height. So the breadth, it is obviously going to be that length. And then this height, it is actually that height where the broken line forms a 90 degree over there. So remember, it started as that, which is actually this part which is not shown because they just wanted to show a a triangle. I'm not sure. Guys, am I losing you there before I go deeper? Are you guys not being confused by what I'm trying to explain over there?
No, sir.
Last one to confirm.
No, sir.
Two indicated not being confused. I'm just not sure. Can I maybe get the last confirmation from one of you guys, whoever who's attending? Can I just get a confirmation from someone?
Yes, sir.
Okay, 100%. So let's just make a tick that we did discuss all that you needed to be aware of regarding the area rule. So remember, guys, it's not my last time doing this lesson, even though it's my first time. But one thing for sure, I'm still going to come back to this information. So now let's maybe try to have a look at the sine rule. Shreyas, your syllabus ends there. So Shreyas, he's in grade 10. So yours end there. From here going down is grade 11s and grade 12s. So just be aware of that. But don't leave. I want you to notice that as soon as you're done with your grade 10 stuff, you continue to this part, which is also not complicated, but it all depends on how well a teacher or a tutor can best explain to you the information there. Okay, so now quickly, let's try to discuss the sine rule. It's pretty much simple, very simple. I'll just keep it short and say, if you have this thing being called a triangle, you can have A there, you can have that point being B and C. This side, ladies and gentlemen, is opposite to that angle, which means is small letter A. This side is opposite to B, which means is small letter b. This side is opposite to a angle C, which means this is small e. So in a triangle, ladies and gentlemen, in any triangle, the sine rule says, remember, sine rule, meaning the trig ratio that we'll be dealing with is sine. It says sine of this angle, sine of angle A, you are going to have over small letter a. This thing is the same as, remember, is the sine rule. So it is sine of, which angle do you choose? Maybe let's choose angle C. That means sine of angle C is going to be over small letter c. Also, this thing is still the same as, if you use angle B, that means it is going to be over that side of small letter b, meaning sine of angle B, it is going to be over a small letter b. I'm not sure, guys. Are you getting that part? Do you notice how easy that is? Mm? Can you guys confirm if you understand what I've just explained? Or is it
Yes,
confusing you
sir.
guys?
I understand, sir.
Okay,
Sir.
100%. Also, this thing, ladies and gentlemen, if you like Tabil, you are not forced to represent it in that manner. If you like, you can just start with the side being at the top and say that means A, it is going to be the same as a sine of angle A, which means you are going to have C being a sine of angle C, which means this thing is actually the same as small letter b over sine of angle b. Whichever way that you write it, it's fine. It doesn't matter. So you can be smart in some questions by writing the formula like this or like that, depending on what the question was asking for you to calculate. I'm going to show you that trick in no time. But before I do that, I would like to try and give you guys and give you guys an example of which we can try to work it out. I'm not sure if you guys are available to try an example. Can you just let me know if all of that made sense so that we can check if there's an example that we can use to try and calculate?
Yes, sure.
Okay, let's see. Let me maybe remove all of these and say maybe we've got a triangle similar to that. Let's say this is A, this is B, this is C, and then this side, let's say we are given 4 meters. Let's say maybe there, let's say there we are given 30 degrees. Let's see. I'm trying to come up with a question from the top of my head. Okay, let's say there we've got 79 degrees. Okay, it's fine. It's just an example, guys. It's just an example. And the question may say, calculate a side AB and also calculate sine AC and also calculate angle B. I'm about to ask you guys a question. You tell me, is this a right-angled triangle? That's my question, the first one. Mention your name and I will recognize you.
Dumela, sir.
Okay, Dumza, go for it. If it's a right-angle triangle, tell me how do you know? If it's not, tell me how do you know? And also tell me, what does it mean if it is a right-angle triangle or if it is not? Based on what you've learned last month, what does it mean, Dumza?
Say, this is not a right angle triangle. Why? Because it is not shown with that sign of, yes, sir.
90 degrees, yes.
Yes, sir. Then for a right angle triangle, it means like we have that sine of 90 degrees, so we're gonna use the trig ratios of sine, tan, and cos, and Pythagoras theorem.
Mm-hmm.
Yes, I think I've answered well.
Okay, so in addition to what you have said, then it means because this one, it is not a right angled triangle, it means we can use the sine rule. And what does the sine rule say? So we just know that the sine rule says it could be sine of, for example, angle A. It is going to be over the side. If it's sine of angle B, it is going to be over B. If it is sine of angle C, it is going to be over C. So now, because the question says calculate AB, remember, if AB is written in capital letters, it means it is the side that they want you to calculate. If they want to write it in small letters, they will just going to say small letter C, because it is the side which is opposite to that. So now, how do you use the sine rule to determine that side? Remember, guys, you can say, let's see, we have that angle and we want that side. We have that angle and we have the opposite side, meaning we can equate and solve. So that means when you use the sine rule, you actually want an angle, and again you want opposite side. It is actually these two things that you want. So let's see. What are we looking for? So if you are looking for a side, write it at the top and say side C or side AB over sine of angle C. And this is going to be equals to, obviously, that side being A, we know it is 4, over sine of, obviously, angle A. Can you guys see? Why did I firstly write that? It is because now it's easy. You just cross multiply and then you are done. So if we have to substitute, maybe let me rewrite that over there. Obviously, we know it's C over sine of, what is angle C? Is it not 30, guys? It's 30 degrees. Equals to, what is the side A? Is it not 4? It is 4. Bantu bagiti. Sine of, what is the opposite angle? Opposite angle is what is 79 degrees. So can you see? This is what I'm looking for. That's why I write it as denominator. If I was looking for the angle, then it means I was going to have my denominator being sine of angle. Why? Because I just cross multiply. So it's more like you see it is actually equals to sine of 30 degrees multiplied by 4 over sine of 79 degrees. Then when you punch all of that on a calculator, what are you guys getting there? Remember, guys, this thing just came out of my head because I wanted to actually explain to you something over there. Let's see, 4 over sine of 79. I'm getting 2. What are you guys getting? Let's see. I'm getting 2,04 meters. What are you guys getting?
Same too, sir.
But Tabile, are these things
Same.
difficult? Shulas is getting 2. Drew, are these things difficult, mate? Yongama, can you see how simple these things are? They are not that much complicated, guys. So now, is there someone who can tell how can we therefore find this side?
Pythagoras theorem.
Remember, guys, in case if you got the question, if you got the question but you don't have an idea of how to work it out, just say so that I can explain to you guys.
Can I answer, sir?
Okay. No idea. Okay, it's fine. I'll explain. Remember, guys, if they want you to therefore calculate that side, if it is the side that they want you to calculate, then formulate based on that side. And also, because it is the side, then you can write small letter b there. That means the formula is going to be small letter b over sine of angle b, which is going to be equals to, use one side and one known angle. I would rather use this one because it was originally given. Just in case, if I calculated that one incorrectly, I'm still safe. So always use the information given if you can. But if not, you can use whatever that you calculated, which means it is going to be the side being small letter a over sine of angle A. Let's substitute. What is B? B is what we are trying to calculate over what is angle B. Angle B, we don't know as yet, but we can calculate. This is going to be equals to what is A? A is 4 over sine of 79 degrees. Do you guys not remember me saying angle A plus angle B plus angle C must be equals to 180 degrees, meaning the interior angles of any triangles must be equals to 180 degrees. I'm not sure if you guys remember me saying that, which means angle A is 79 degrees, plus angle B is what we want to know, plus angle C is 30 degrees. All of these must be equals to 180 degrees, which means angle B, what is it? So that means it is going to be 180 minus 30 minus 79 is 71. 71, yes, 71 degrees. So that means already we have indirectly answered that question. So now let's continue. Can you now see we have that angle, which means we can easily calculate that side, which is going to be a B is going to be equals to, you just cross multiply. So that means you have sine of 71 multiplied by, obviously there is 4 over sine of 79. Therefore, what is that side?
It's 3.85.
What is it? 3.85. Are you all getting 3.85? No, 3.85. Yes. Are you all getting that?
Yes, I'm getting the same answer.
Yes, sir.
Okay. 100%. Ladies and gentlemen, this is all that I wanted you guys to be aware of regarding the sine rule. Let's make a tick over there. Do you guys allow me to move to cosine rule, or is there someone who's got a question regarding the sine rule?
Can move on, sir.
100%. So these things, ladies and gentlemen, they are not that much complicated. What makes them to be complicated is when at your school, the teacher just takes you through question papers without having to take you through an introduction, of which I believe they do take you through an introduction. You just fail because questions are being asked in a tricky way, which is what I'm going to be taking you through throughout the week. Just make sure not to miss upcoming lessons because we'll be doing some easy to complicated questions. But one thing for sure, with my lessons, you will understand, and what will be remaining will be for you to just keep on practicing. Okay, can you guys see we are now on the cosine rule? The cos rule. Hey, good people, in today's lesson, we are only focusing on a triangle. But remember, we've got a right angled triangle and we have just a triangle, of which it's what I'm actually taking you through in today's lesson. Let's say, for example, also we still have A, we have B, we have C. This side is going to be smaller than A, that is going to be smaller than B, that is going to be what is it, smaller than C, and then smaller than B. The cosine rule. What is the cosine rule saying? Also easy, this one. Very, very easy. So, the cosine rule, ladies and gentlemen, this is how it works. You concentrate on the side, and also the angle in between. You concentrate on the side, which could be that one. You concentrate on the side, which could be that one, and the angle in between. How easy is that, ladies and gentlemen? You concentrate on the side, which could be that one. You concentrate on the side, which could be that one, and the angle in between. Easy, 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 easy. That is how the formula for the cosine rule is formulated. You just need to know it by heart, even though it is given in your formula sheet. But for me, I've always wanted to know them by heart because I understood where they come from, how they were derived, of which it's something that I don't want to confuse you with in today's lesson. I don't want to show you how they derived these formulas. I want you guys to firstly understand how they are and also how you apply the formulas. At a later stage, when I derive, that's when it's going to make a perfect sense. Okay, let's see. So now, maybe let's do for that angle B. So the cosine rule, it actually helps us to calculate the side. So which side would you guys like for me to formulate using the cosine rule? Which side? You can just choose any side.
C, sir.
C. Okay. So this is side C is opposite to that angle, which means I'm going to formulate using this side and also this side and the angle in between. So let's see. There is C. So that means we have C squared, which is going to be equals to. You can start with this side or that side. Alphabetically, which letter comes first is A, then B. Maybe let's start with A. Then it's going to be A squared plus B squared minus 2 of those same letters being A times B. Because it's the cosine rule, then we say cos of the angle. Which angle? That same angle over there being angle C. Choose another side. I will formulate.
A.
Okay, where's A? There is A. So that means it's opposite to that angle, which means when I formulate, I'm going to concentrate on this side and that side and the angle in between. So because it is A, which is the side that we are looking for, that means it is going to be equals to, okay, between this side and this side, alphabetically, or with model A English, alphabetically, which letter comes first? It's A, what is it? B. So that means I'm going to have B squared plus C squared minus 2 of the same letters, meaning it's 2 times B times A C multiplied by or times, because it is the cosine rule, then it's going to be cos of that angle being angle A. I'm not sure if you guys are noticing something there. Obviously, the last side is what? Is B. Okay, meaning it is going to be B squared, which is going to be equals to, where's, oh, there's B. So that means this side, that side, and the angle in between. Let's see. Which sides? That's, okay, alphabetically, A comes first, which means it is going to be A squared plus A C squared minus 2 of those same letters being A times C. Because it is the cosine rule, it is going to be cos of what? Of angle B. Guys, you tell me, are you not happy with what I've just explained over there? Is it not easy, guys? Is it not understandable, ladies and gentlemen?
Sir.
Yes, sir.
Yes, sir.
I'm happy, sir.
So what I'm going to do quickly is to give you guys an example of which I'm going to do it for you guys for today. So let's say we have a triangle similar to that. Let's say this is R, this is P, this is Q. Let's say this side is 462 or 62. This one is 378. Maybe this angle, we make it 87 degrees. So in this case, remember guys, for every triangle that you are given, you ask yourself if it is a right-angled triangle. If an answer to that question is yes, then you cannot use the sine and the cosine rule, but you use the trig ratios and the theorem of Pythagoras. But if it is not a right-angled triangle, it means you must use either the sine rule or the cosine rule. But how do you know which sign, which rule can you use? So if you have noticed, the sine rule is more about angles. So if you have more angles and one side, obviously one or more, then it means you can use the sine rule. You remember the sine rule would be, let's say, a sine of angle A over small a being equals to, let's say, sine of angle B over a small b. So can you guys see we have more angles that we need to substitute, which is an angle there, which is an angle there. Then we just need one side, which could be this one or that one, in order for you to calculate the other unknown sine. So you only use the cosine rule or the cos rule if you therefore have more sides, being vice versa. If you have more sides and one angle is enough. Because you've noticed that you are going to deal with one side, another side, and just one angle. Here comes a question. In this case, who can give a sermon and a prayer according to that triangle over there? Mention your name and I will recognize you, honorable member. I wonder if we are going to have Mamfundisi or Mufundisi in this case. Let's see. What are we going to have? Pastor Andrew, do you not want to give a sermon, Bloda? Bloda? Tumza wants to be our Mamfundis. Okay, Tumza, go for it.
Okay, so since we have an angle on the sides, so we're gonna use the cosine rule, which says. So what are we looking at? Oh, we're gonna use the cosine rule, which says r squared.
Okay.
Small letter r. Small letter
Okay.
R.
Let's say in this case, the question may say, find all sides and all angles. You just need to know where to start. Tumza, continue.
Okay, so now I'm starting with side PQ, which is the small letter r. Right?
Yes.
Then it's gonna be r squared. Is equals to p squared plus q squared, like the small letters.
Yes, p squared being this side, and then small letter q being that side. Yes. Obviously minus 2pq multiplied by cos of angle r. I agree with you there, honorable member, and I assume everyone agrees with you on that one. Can we all therefore substitute? What is p? There is p is 378 squared plus what is q? There is q 462 squared minus 2. Then you just say into 378. What is that? This is 462. Then you have cos of, what is the angle? The angle is 70 that degrees. Then what are you guys getting when you punch all of that on your calculator? Hey guys, me, I'm eating. I don't know who want to join me. I'm eating here. I'm eating a crocodile. Not sure if this as someone in this group who eats a crocodile. I'm chewing the tail now. Very nice. Very, very nice. And I'm drinking umqombothi here. Just in case if when I write wrong stuff, just know that I'm now getting drunk. Hey.
So the answer.
Mm.
The final one, right, sir?
No. Before we get to the final answer, let's maybe write that one, which is all over. Spiwo Zwane. Are you getting the answer there?
Do you want the R squared or do you want R?
No, the R squared. Hey, why are you guys taking
So
for
I'm getting
ever?
343,628,52.
Hey,
5159.
hey, that number, even Zuma wouldn't survive that one. Hey, it's a big number. Let me just punch it so that I can see it. 462. Hey, that's a big number there, honorable member. 338. 338. No, 338 and 48.5159. Okay, yes. Then now to get R, we have to do the square root of an answer. So you just punch the square root, then you say answer is equals to. Is this what you guys are also getting if we round it to 2 decimal places?
Yes, sir. It's the same answer.
Yes, sir.
Okay. Are you all happy with that calculation, guys? Does it make sense to everyone?
Yes, sir.
Okay, 100%. So now remember, the question said calculate or find all the sides and all the angles. So now, can you see? We have the side, we have the angle. We have the side, we can try to calculate maybe that angle. Let's see. Can we not just use the sine rule? I think we can. So because we're looking for the angle in this case, that is why I'm going to write at the top sine of angle P. This is obviously over the opposite side being P, meaning this is going to be equals to. I can just maybe use that, which is what I've just calculated, to say sine of let me just substitute. Okay, no, before, let me just not substitute and formulate. This is sine R over small r. So can you guys see? It is that we are trying to calculate. So you can just cross multiply, meaning you end up having sine of angle P is equals to P being that multiplying sine of angle R over that R. So what is P? There is P, we know is 378, then sine of angle. No. It's sine of angle R from the formula there. Angle R is 87 degrees over. What is small r? Oh, we calculated it is 5 that point that. Then obviously you are going to punch all of this. But because you're looking for that, that means angle P, it is going to be equals to arcsine of the whole of this that you punched on a calculator. So what are you guys getting as your final answer? I hope you guys understood that calculation. In case if you didn't, just make sure so that I re-explain it. But I don't think you guys got confused. What will therefore be angle P?
So it's 40,48.
Are you all getting the same answer? You're saying 40,48.
Yes, sir.
40,48. Are you all getting the same answer?
So,
Okay. So now, what will that angle be? Mhm.
So it's gonna be 52,5 degrees.
But now, how do you get to that answer?
Oh, so the sum of the triangle. Sum of the triangle.
Yes, some of the interior. Some of the interior angles of a triangle add up to 108, which means that angle P, we just calculated it to be 40,48, plus the one for R is 87, plus this one for Q is what we are trying to calculate. Then what is that? Is this minus that minus that? What are you getting? I got this thing. Is this what you guys are getting as well? Nice.
yes, sir.
Last one to confirm. Hey, guys, are you still there? Maybe it's the network. Okay, it's fine. I suppose all of you guys got that same answer as Shreyas has confirmed over there. So let me just quickly get another board. I just want to quickly take you through something. Okay. It doesn't need to be 100% clear because I want you guys to try and work on it. We are actually nearing the end of our lesson for today, of which I hope you guys did enjoy today's lesson. I'm not sure. Can you guys see over there, or is it blurry?
You can see, sir.
So I can see.
Okay, 100%. So, this is a question that was sent in the group. And I'm telling you now that this is taken from a past question paper. I'm not sure, guys. Based on our lesson for today, do you think you can fail to answer this question in exam? 3 marks. Is this a right-angled triangle? No. So if the answer is no, then it means whatever side that you can calculate, it's either you use the sine or the cosine rule. So you read the statement, and based on what the question wants, you will therefore know which rule to use. In the diagram, angle P67, PQ, which is 3 centimeters, PR, which is 9.2 centimeters, determine the length of QR. Can someone just indicate if they can be able to answer that? And which rule are you going to use?
Yes, sir. Cosine Rule.
Do you guys agree with that?
Yes, sir. Yes, sir. Cosine.
Easy, 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 easy. Let's see. 1 mark, 4 mark, 2 mark, 3 mark. Okay. There we have. I think let me quickly try to redraw this one. And then what I'm going to do is just to explain. Then on your own, you'll try to answer that. And then in tomorrow's lesson, we'll be doing some corrections. Let's see. Let me just try to redraw that one. So I so wish all of you guys can attend all of my lessons and never miss, because once you do a chapter with me, I don't think it gets difficult to understand upcoming lessons, of which I'm giving you the tricks that you can apply in your exam. I'm telling you guys, I taught myself these things, and with the information that I had, or I was able to teach myself, I managed to get distinctions in mathematics. That's why I believe with you guys and your good teachers, you will be able to get 100% in mathematics. It's not that much difficult. Okay, so maybe let me be the one who's going to preach there. Before I even do that, let's see what information are we given. So they say in the diagram below, triangle DCB but angle C. Triangle DBC. The letter in the middle is the angle. Therefore, angle C is alpha. Yes, no, I agree there. AB, no, AC is equals to H. Where's H? Oh, there. There is H. No, AC being H units. And in triangle ACB, where is A? There is A, there is C, there is B, or the bigger triangle. Angle C is theta. Yes, I agree. No, I agree. Okay, I agree. Before I even now start answering the questions, this is what I'm going to ask myself. I'm going to say, am I seeing a right angled triangle there? Am I seeing just a triangle? And also, how many triangles can I see there? Me, I see 3. I'm not sure about you guys, but me, I see 3. Okay, I see this one, the bigger one. The bigger one. Also, it is a right-angled triangle. The bigger one. Me, I see 3. The other one is this one. Also, it is a right-angled triangle. There is C, there is B, there is D. Me, I see 3 triangles. C, A, and D. Remember, this angle, it is that 2 there, and then that one there, which is going to be that one, is that one 1. And also, in triangle ACB, where's, oh, there's ACB. Oh, this is where you have theta there. So it's actually in this one where you have alpha. Can you guys see how you interpret the given information, guys? Very, very much important. Otherwise, if you do not pay full attention, I'm telling you guys, you are going to struggle. Guys, do you agree with me there? Hmm? Hallelujah. Evan, o ka re kereke e tswile na. Apa se tswe ke rapele makgowa. Ana o ka re se le tswile kereke na. Libandla la kaNkulunkulu lisasekhona lapha enkonzweni. Hey, Lee, ukhona lapha? Yongamas yo. The doom is Grace. Grace, can you greet me? Tabile Madoyeni, welcome to my lesson. Nangamso Majola, welcome. Mpoza, welcome. Spiwo Zwani, welcome. Guys, are you there? Do you agree with me on that one?
Yes, sir.
Okay, 100%. So let's see. The question here says, determine the size of, when this thing is written like this, it means concentrate on this triangle and then give the angle of C. So here they say determine the sine of ACD triangle. C is what they want you to yo. This is what you do, guys. They want you to concentrate on triangle ACD. Where's triangle ACD? ACD. Okay, meaning it is this one, and they want you to calculate that angle, which is actually this angle. And they say in terms of that, and it's given 1 mark. I'm not going to go deep on that one. I'll just leave it there. So here they say prove that AD is equals to all of that. Let's see, where is AD? And this is allocated 4 marks. So where is AD? There is AD. And you can see AD, it is actually in this triangle of ADC, which is in this one. So that means based on the information that you have, we know we have h, which is that h being given. We also have that angle. And they want you to show that AD is equal to something. So this is how you approach it. Because you know, or you can see, this is not a right-angled triangle. It means you might need to use the cosine or the sine rule. It all depends on the information given. So you have this side being C. You just calculated the angle in the previous question. So you can maybe say this side over whatever over whatever, or you can use the cosine rule if possible. I hope you guys, you do understand that part, or otherwise, if necessary, you can use this right-angled triangle, maybe to find information about that side, and then from there, you are going to have enough information maybe to use the cosine rule, or you can stick on the sine rule. It all depends on the information that you are given. So the reason why I'm not going deep is because I want you guys to give it a try so that tomorrow when we tackle that, you guys have got an idea of where to start. Then I'll take you through everything. And the next question says, determine the length of AD. Where's AD? There is AD. And they say that's if H is equals to 17 units, and then theta is equals to 58, and then that alpha is equals to 23 degrees. Of which someone clever, they know what to do over there. You will discover more of that when we do corrections tomorrow. The last question is, calculate the area of triangle ADC. ADC, yo. This examiner, he's actually focusing on that triangle, which is not a right angled triangle. And this question is allocated 3 marks. So, because this is not a right angled triangle, that means you might need to come up with all the information that you need in order to calculate that area. But you remember, guys, we said this, the longest side is going to be your base. And then your height, it is going to have to be that one that you can use on the formula of area being half the base times a height perpendicular. This is the height perpendicular because it forms a 90-degree angle there. Or otherwise, a smart learner would actually calculate the area of that big triangle and then again minus the area of this small triangle. Then you know you remain with the area of that triangle, in case if you don't want to complicate your life. I'm not sure, ladies and gentlemen, this brings us to the end of our lesson for today, and I hope you guys did learn something new, and I hope you guys are now a bit confident and you will never skip this question again. Guys, are you happy there? Bantwana bakaNkulunkulu lisasekhona lapho noma cha? Or seseholo ke bophelo? Haibo.
Yeah, fine, sir.
Ladies and gentlemen, thanks very much for joining. You guys have a very good night. My name is Desmond, and I'm out.
Thank you, sir.
Thank you, sir.